Fresh waste will be delivered by EDMC through the existing dump site into the MSW pit. The leachate present in the garbage will be allowed to flow into the collection pit through the leachate openings. For treatment of this leachate, an advanced leachate treatment plant has been designed and set up at the plant premises. Physiochemical treatment of leachate will be carried out, followed by two-stage biological treatment using PVA gel technology from Japan. The treated water will then be used for horticulture. Once the waste is received in the MSW pit, the grab operator will mix the waste to bring about partial uniformity. The waste is then fed into the feeding hoppers with the help of the grab buckets. The moving bed feeder fitted below the feeding hopper will feed the MSW to the slow-moving conveyor where manual sorting will be carried out to separate oversized material, boulders, dead animals, etc. The hand-sorted MSW will then be taken on a common conveyor. Thereafter, the entire material will be fed into the 100 mm trommels for screening. The 100 mm trommels will also have bag rippers. However, through a bypass chute, material can also be taken directly to the shredder. Plus 100 mm material coming out from 100 mm trommel will be subjected to magnetic separator and then will be taken to the shredder feeder conveyor at 4 meter level. Minus 100 mm material will be fed into another trommel which has a 16 mm screen and a 25 mm screen. Minus 16 mm material is inert and will be transported to the landfill. Plus 16 mm and minus 25 mm material is the organically rich fraction which will also be subjected to magnetic separator and will then be transported to the Okla compost plant for composting. The oversized combustible material separated by manual sorting and the plus 100 mm material coming out from the 100 mm trommel will be fed to the shredder placed at the ground level through the shredder feeder conveyor. These are the world's biggest shredders named Tyrannosaurus from BMH Finland, having crushing capacity of 30 to 40 tons of waste per hour. Plus 25 mm and minus 100 mm material will be subjected to magnetic separation. Thereafter, it will join the stream after shredder. The complete sized material will then be conveyed to a rotary dryer that will draw hot air from the hot air generator. The dryer gas cleaning system comprises the Venturi scrubber, demister, and carbon bed. The dried material will then be subjected to air density separation and the lighter fraction, which is RDF, will be collected in a storage pit from where it will be fed into the boiler. To fulfill the process water requirement and other water requirements at the plant, treated sewage water will be supplied from the DJB pumping station at Kondli. The primary and secondary treatment of this water will be carried out at the water treatment plant at Varun Enclave. The treated water will then be transported to the Ghazipur waste to energy site where tertiary treatment of this water will be carried out to meet the boiler feed water quality. This water will be passed through deaerator before feeding it into the boiler. The RDF will be burnt in the boiler to produce 57.9 tons per hour steam at 41 bar pressure and 400 degrees centigrade. This steam will be used to drive the steam turbine to generate 12 megawatt of green power. Air-cooled condenser will condense the exhaust steam from the turbine generator, hence reducing the water requirement of the plant to a large extent. The emission control system will comply with the Euro norms of emission standards. The flue gases will be treated in a system comprising multiple stages for effluent reduction. The chief components of this design are the lime injection system, the semi-wet reactor, activated carbon, and a set of bag filters. The remaining power after internal consumption will be evacuated through the 66 by 11 kV switchyard at the Ghazipur waste to energy site to the 220 by 66 kV DTL bay at Ghazipur.